See, this is the last day of review. So starting with 32, we're going to go through to 43, but I think we're going to skip number 41 because 41 is exactly the same thing as what 39 and 40 are. So we'll skip 41. So 10 problems left. Hopefully they go by fast, but 32 and 33 come from chapter 7, which is logs. So rearranging logs or rewriting logs. Um, so 32, they want us to solve that thing. And whenever you have a log and you're trying to solve it, I usually always convert it to an exponential function. Whenever you have an exponential function and you're trying to solve for it, you insert a log. So you might ln both sides or whatever. But in this case, I'm going to switch this to an exponential function. Okay. And he's kind of weird because he's got a big, huge piece here in the middle, but that's okay. The base is going to stay the same, so the base is going to be 3. And then I just switch my numbers around. So 3 to the negative first power is going to be equal to 1 minus x. And then we just have to solve for x, okay? 3 to the negative first power is 1/3, okay? That negative exponent makes them a fraction. So I have 1 minus x, and then I'm going to subtract 1 from both sides. So 1/3 minus 1 is going to give me a negative 2/3 equals negative x. And then if I just flip the exponents, I'll have, or flip the signs, or divide by a negative, I guess, x will be positive 2/3, and that's what he will look like. Okay, so pretty easy for that one. Number 33, I went ahead and wrote the equation for half-life. Half-life of a radioactive element, this is uranium, is 245,500 years. This is the formula for half-life. So A is the after amount, P is the principal, T is the time, and then K is the half-life of each individual element. So that K will change based off of what element you're talking about. So like if we're talking about carbon-14, it's like 5280 or something is the half-life for that. So that K is determined by this number right here. So I'm going to go ahead and mark him as K. What percent of a present amount of radioactive uranium will remain after 500 years? Okay, so they tell me what percent, which is kind of a weird way of asking for this. So let's do this. They don't give me a principal amount, but what I'm going to do is I'm going to plug in 100 in for this, okay? And then plug in all my other values in. So I have K, I have T, and then what I'm going to do is the after amount will tell me what portion of 100 is left. Okay, and the reason why I use 100 is because percentages are out of 100. So you could have used 1 if you wanted to. You could have used any number in this spot, but 100 makes the most sense to me because this I'm thinking of this as being starting at 100%, what would be left for the after amount. Okay, so I'm going to go ahead and write this in here. We're solving for A, starting with 100. We're assuming that we're starting with 100. You know, we don't know how many grams or whatever we're really starting with, but this will give us a nice, easy way to convert this to a fraction, or to a decimal, okay? So now I'm just plugging this stuff in. Let's see how this works here. I have 100 times 0.5 to the, I'm going to open up parentheses, 5,000 divided by 245. I'm guessing that there's still going to be quite a bit of it left, because if it takes 245,000 years to split in half, 5,000 years is probably not going to do a whole lot. Yep, 98.6 is what I got. So out of the 100 grams, 98.6 grams is what's left over or whatever. So if A is equal to 98.6, that's kind of like saying 98.6% because we were out of 100 to start with. Okay, so that was kind of the tricky part. They didn't give you a P, so we can just assume P is whatever we want it to be. I chose 100 because it's easier to do that. Okay, all right, so now we have chapter 8, which we did 3 sections of, so we should be able to do all these problems. There's like 5 of these. But chapter 8 had derivatives and antiderivatives of logs in the same problem, okay? And so, or in the same chapter. So what I'm going to do is 34 is a derivative, 35 is a derivative, and 37 is a derivative. So we're going to skip 36. We'll do 34, 35, 37, and then we'll come back and do 36, then 38, so that we can do all the derivatives together, all of the antiderivatives together. It's just going to be easier to do it that way. So find the derivative of this thing, okay? I'm going to write out this e to the x power. If I'm doing dx, e to the x power, his derivative is just e to the x, okay? So e to the x, the derivative of e to the x is just e to the x, okay? So that was one of the things that we had. And so here I have e to the t power, so when I find his derivative, he's just going to be e to the t power. But since I have that t squared in front, this is technically a product. Okay, so I have to use the product rule. F prime g plus g prime f. So where this guy is f, this guy is g. Okay, so f prime, I want to take the derivative of t squared, so 2t in that case. G stays the same, so e to the t power. Okay, and then I have plus g prime, which is the derivative of e to the t, which we said was just still e to the t, times f, which is t squared. Okay, and I can't put those together because this one is a t and this one is a t squared. What I could do is put my t's first, kind of like this one was. So 2t e to the t plus t squared e to the t. That's what he will be as my derivative. Okay. Moving on to the second one. So this guy right here, when you're taking the derivative of something that's not e to the x, like if I have e to the u, his derivative turns into e to the u times u prime. So I have to take the antiderivative, or excuse me, the derivative of the exponent as well, okay, and then multiply that down in front. So that 3 is not going to change anything. I don't technically need to do the product rule here because the 3 doesn't change. But my exponent up here, negative 3 over x, he will change, okay? So the first thing I want to do is rewrite the whole thing, e to the u. So 3e to the negative 3 over x. Okay, that's what his derivative, or that's the first part of this. And then I just need to find the derivative of the exponent. Okay, so I'm going to multiply that guy by, I need to take the derivative of the exponent. Okay, so negative 3 over x. If I move that x to the top, he'll be x to the negative 1 power. Okay, and then I need to find the derivative of that. So bring the negative 1 down in front. That'll make it positive 3x to the negative 2, which, if I change it back, will be 3 over x squared. Okay, so I'm going to take this guy and multiply by 3 over x squared. That's what my u prime is. And then I can go ahead and I'm going to lump these two front and back together. So 3 times 3 over x squared is going to be 9 over x squared. And then I just have e to the negative 3 over x. That's what he will look like as a derivative. Okay, so not too bad yet. Now 37. Okay, when we're doing ln's, the derivative of an ln, so like let's say the derivative of ln of x is 1 over x. Okay, if I have like let's say the derivative or ln of let's say x squared. Okay, if it's not just x, the derivative of ln of x squared. Okay, I leave the bottom the same, but I take the derivative of the top. So this would be 2x over x squared. Okay, which is kind of like what we did here. X stayed the same at the bottom, and then the derivative of x was just 1. So that's kind of how that rule works, okay? But when we're doing this guy, okay, what I want to do is before I even try to take the derivative, I'm going to break him apart, okay? I have lots of pieces here. These two are being multiplied together, and these things are being divided, okay? So I can do addition, subtraction, and kind of break him apart, and here's what he will look like. So ln of x is what I'm going to start with, okay? Ln of x, okay? Then I have plus, because that's multiplied together. Then I have ln of x minus 1, okay? And then, since this is being divided, I can do minus ln of x minus 2. Okay, so that kind of makes everything really nice. And then I just take the derivative of each piece individually. Okay, so the derivative of ln of x is 1 over x. We just said that. Okay, this guy's derivative, so I'm going to do plus. The bottom stays x minus 1, but then I do the derivative of x minus 1 on the top, which is just 1 still, okay, minus x minus 2 stays on the bottom. The derivative of x minus 2 is 1, that goes on the top, and here is what my derivative of all 3 of those pieces are, okay. So that makes it really nice if I separate him out to start with, and he looks really easy. Okay, to start with, he kind of is ugly, all right. So let's bump back up and we'll do 36 and 38. Those are antiderivatives, okay. And mostly what that's going to involve is using substitution. So when I look at this, I have kind of a product going on here. And I'm hoping that when I do substitution, my x squared is going to end up going away or canceling out. So I need to figure out what u is, and I need to figure out what du is. Okay, and I need to pick really nice ones. So hopefully that x squared will cancel out. So u is always going to be the exponent whenever you have an e in there. So x cubed plus 1. And then I need to find the derivative of that for my du. So 3x squared dx is what my du will be. Okay, and then I'm going to plug stuff back in. So I have my integral here. I know that this is going to change to be e to the u. That's what this part becomes. Okay, and then I need to get rid of an x squared dx. Okay, so x squared dx is this part right here, but I don't have that 3 there, so I'm going to get rid of the 3 and bump him to the other side. So x squared dx I can replace with 1/3 du is what he's going to look like, and then I just need to find the antiderivative of that. Okay?
Mom!
What, honey?
Did Daddy take it?
Shh, I don't know, honey. Shh, you have to be quiet.
Did Daddy take it?
Did Daddy take what?
Dad took my milk.
He took your milk away.
Yeah.
Why did he take your milk away?
Because
Because
he hid it somewhere.
I don't know what he did. Okay, you go downstairs and you go find it. Okay, and then you come tell me where it is. Okay.
I'm downstairs.
All right, you go on downstairs. Can you go downstairs and see if you can find it?
No, I can't.
Yes, go downstairs. It's in your bed. Go downstairs. I will be right there. I'll come down in just a minute.
No.
Brad!
Just get out of my bed.
All right, go downstairs. Go on. Go on downstairs. Bradley! Okay, so we just need to find the antiderivative of 1/3 e to the u, and the antiderivative of e to the u is still just e to the u. So this will be 1/3 e to the u plus c, okay, is his antiderivative. And then I just need to plug back in for u, so 1/3 e to the x cubed plus 1 power plus c. That's what his antiderivative will be. Okay, so that one comes out really nice. All right, same thing for this one. Let's go ahead and we need to have a, let's see, we need to have a u and a du. So I'm going to say u is going to be the bottom part, x squared minus 1. Du is going to be 2x dx, okay, the derivative of x squared. All right, now I'm going to start plugging things in. So my integral, x squared minus 1 is u, so I'm going to put that on the bottom there. Okay, and now I need to get rid of an x dx. So I see that x dx shows up in my antiderivative there, but I need to get rid of the 2. So I'm going to make that 1/2 du. So I'm going to replace him. 1/2 du is going to look like that. Okay, and then there was nothing up on the top here, so I'm just going to make it a 1. And now I have everything replaced, and I just need to find the antiderivative of 1 over u. Well, we said that the derivative of ln of x was 1 over u, so the antiderivative is going to be ln of x, except the only deal is that it needs to be ln absolute value of u. Okay, and we kind of went through why that is when we did this, the notes for this section. Plus c, and then I replaced my u, so I have 1/2 ln absolute value of x squared minus 1 plus c, and that's what he will look like. Okay, so I almost think that finding the antiderivative and derivative of ln's and e's are a lot easier even than just like the regular functions. They come out really nice. Okay, all right, so solving the triangle, 39 and 40 are going to involve the law of sines, law of cosines. So we'll do those two, and we'll do 42 and 43, and then we'll be done. So 39, we have two angles here, okay? And then we have one side that we have here listed, but then we have angle C that we don't know, and side B and side C that we don't know, okay? So we're going to figure out what those guys are. I'm going to make a list off to the side over here. I just always like to take kind of an inventory so I can see what's happening. A, B, C. Okay, so capital A is 25 degrees. Capital B is 35 degrees. Now, I can find what capital C is pretty easily if I add those up and subtract from 180. So let's go ahead and do that. 25 plus 35, and I'm going to take 180 minus that answer, 120. I should have been able to do that in my head, but that's okay. 120 degrees. Okay, now, law of sines and law of cosines. Oh boy, I'm kind of running out of room. Law of sines, I think we did like sine A over A equals sine B over B, something like that. Or maybe it was A over sine A, B over sine B. It doesn't matter which way you write it. That's the law of sines. So if we are given two angles, two sides, then we're going to use the law of sines. Well, I do have two angles, really. I have three angles. And I have one side. So what I could do is I could use this law of sines, use this as my first piece, and then solve for B here as my second fraction. So let's go ahead and do that. Okay, so I have sine of 25 over 3.5 equals sine 35 over B. Okay, and then I'm going to cross multiply. So I'm going to multiply these guys. Okay, then to get B by itself, I would multiply those guys and divide by sine of 25. So if you need to write that out, go ahead and do that. But I'm just gonna multiply 3.5 sine 35, and then I'm going to get that answer and divide that by sine of 25. And then you make sure I'm in degrees. Yes, I am in degrees. If your calculator is not in degrees, you'll get a different answer. So be careful of that. So B is 4.8. Let's see, 4.8. Okay. Now, yes, I see. Okay, now for C, I can do the same thing again, except instead of, so I can still use sine of 25 over 3.5 for A, and then I need to change this to be C, and change this guy to be 120, and then I can do the same thing again. So I don't even really need to rewrite anything. I can just take it times a different piece. Okay, so I have 3.5 sine of 120. And then I'm going to divide that by sine of 25. Okay, and 7.2 is what C will be. So that's what he will look like. Honey, your cup is downstairs.
No, it's not.
Yes, it is downstairs. I gave it to you. It is not in there. Go downstairs.
No.
Yes, go on.
No.
Malia Jade, go downstairs, please. Bradley! Honey, it's downstairs in your bed.
No, it's not.
Yes, it is. It is in your bed. Go look for it. Brad! Go take it downstairs. Go take that downstairs and show it to Daddy. Go on. Okay. Now, number 40. Here we only have one angle, and we have kind of like three sides going on here, even though we don't know what side C is. But this one's going to involve the law of cosines. Okay, so I'm going to use some room down here since we're not going to do number 41. Law of cosines is a squared equals b squared plus c squared minus 2bc cosine of capital A. That's what he looks like. Okay, so we have three sides, one angle. So we're going to be solving for lowercase c in this case, probably first. Okay, so I'm going to write this out. A, B, C, and lowercase a, lowercase b, lowercase c. Okay, 105 is what we know is here. Capital A is 10, lowercase a is 10, lowercase b is 4.5. Okay, so we're going to use this to solve for c first. So in this case, even though they call this A and A, those are actually going to be my c values because the only angle that I know is 105, And so this is going to be C in this case. So really, this is actually technically A, and this is technically A here. Okay, so I'm just going to plug those guys in. So I will have C squared equals b squared 4.5 squared plus 10 squared minus 2 times 4.5 times 10 times cosine of 105. Okay, all right, now I should be able to, you can do this in pieces if you want to, but I'm going to try to just plug this all in at one shot into my calculator and see how it goes. I have 4.5 squared. As long as I type this in right, or the way that it is here, it should do the order of operations correct. So 4.5 squared plus 10 squared minus 2 times 4.5 times 10 times cosine of 105. Whoa. Those parentheses there. Okay. And I get 143.5-ish. And that is just what C squared is. Okay, but then I need C, so I'm going to do the square root of the answer. And I get 11.98. Yeah, we'll go ahead and write 11.98 because I don't want to round it up. 12.0. Okay, it could be 12.0 if you want to do one decimal place. So that's what he will look like. Okay, then what we can do is we can use the law of sines with this guy, and sure, let's do A next. Okay, so law of sines with those guys. So I'm going to do sine of 105 over 11.98 equals sine of capital A over 10. Okay, and now this one's going to be kind of a weird one because when we do our law of sines, I'm going to, our cross multiply, we'll multiply those two together, so I'm going to take 10 times sine of 105 and divide by 11.98. So let's do that to start with. 10 sine of 105 divided by 11.98, and I get 0.8 something. That does not seem like a right answer, but keep in mind that that is only sine of A. That is not A itself, so 0.806 or something like that, okay? Now to get just A, we have to do the inverse sine. So second sine of that answer, gosh dang it. And now it's not going to give me the right answer because I hit the button wrong. Maybe that's right, 53.7, we'll find out. Seconds, that's why I write everything down. 0.806. Oh, it was right, 53.7. Okay, so not too bad. All right, so A is 53.7, and then what I can do is I can just add that to 105 and then subtract from 180. So plus 105 and then 180 minus that answer is 21.3. Okay, so there is me solving a bunch of stuff. Okay, all right, next, last, we've got some systems of equations. So 42, I might just have you guys do 42 by yourself. So you should be able to do elimination. Try eliminating the y's. Maybe that would be really nice to do. So you guys do that, and I will get an answer, and then we'll check at the end. So. Okay, so for 42, I got this really ugly decimal thing there, negative 2.92 and negative 1.14. You might have rounded differently than I did, and that's okay, but as long as it's close to that. And I did go ahead and plug it back in to check to make sure that that was the right answer. So there's 42. Now 43, we have to make some decisions on what variable we want to eliminate. So I see right off the bat that, oh, this kind of makes it nice. If I just add these two equations together, those top two, I see the y's cancel and the z's cancel. So let's just see what happens there. Let's just add those two together. So 2x minus 3x, that will make negative x. The y's will cancel, the z's will cancel, and then I'll have negative 3. So x will be equal to 3. Aha, there we go. That's really nice to start with. Perfect. Okay, so now what do we do from there? Usually we don't have two variables that cancel. But that was kind of nice. So let's do this. Let's go ahead and take like the second and third equation now, and let's plug that x in for each one of those, and we'll get an answer here. So if I plug 3 in to this top equation, I'll have negative 3 times 3, which is negative 9. And then what I'm going to do is I'm going to bump that 9. I'm going to add the 9 over here to the other side. So I will have 2y plus 6z equals 10. That's what I'll have on that side. Okay, and I'm going to do the same thing here. So if I plug 3 in for this x, and then I subtract that 3 to this side, I will have negative y minus 5z equals, I think, negative 6, something like that. Okay. All right, now I can just do my elimination now with just those two equations. So I'm going to multiply this guy by 2. So this will be negative 2y minus 10z equals negative 12 if I multiply him through by 2. Okay. So then my y's will cancel. I'll have negative 4z equals, negative 2. I'm going to have a fraction here. If I divide by negative 4, z is going to be 1/2. Okay, so I have my z variable now. Now I can go back up here, maybe to that equation, since the other one's kind of messy now. And I can plug in 2y plus 6 times 1/2 equals 10. And then we'll get an answer there for that guy. Okay. So half of 6 is 3, and if I subtract 3, I'll have 2y equals 7, and divide by 2, so y is 3.5, or 3.5. So let's go ahead and write that out as one whole ordered triple. I'll have 3, 3.5, and I'll do 0.5. I'll put them all as decimals there. Okay, so there is that. All right, you are done. Yay, how exciting. You are done with high school calculus. I'm very proud of all that you guys have accomplished this year. You guys have been rock awesome. I don't think I've ever had a group that's actually stayed with me this long. You know, like I know that we ended at third quarter, but usually I have seniors that are wanting to check out by then. So I appreciate that. I'm going to miss you guys. I better not stay on too much longer. I'm going to start tearing up because I'm hormonal and pregnant, so I will log off. But don't be a stranger.